problem number 1. By the way, I have just printed this. This is my answer key, and you can use it and you can change all the yellow numbers. See, I've got it printed out here. So I'm not going to be doing my calculations. I'm going to be referring to this, but they should be right. We're filling stuff in here, at least on number 1, working there. So I can have a nice big diagram. Point of this problem is to figure out the acceleration of the box, but you get points for doing all these intermediate steps. I guess I'll just go in order and draw things as I go. The box weight, so let me draw the weight. There's the weight. And I'm going to put my W over here because I'm going to want to, and I'll go ahead and do this, I'm going to want to resolve this into the perpendicular component of weight and the parallel component of weight. So weight is just mg, which is 5, that's the mass, times 9.8, and that comes out to 49. Units are newtons, the direction is down. So just going to write 49 newtons there. A little bit messy, not too bad. Now, perpendicular component of weight. I'm given the angle of incline, so this is a 70-degree angle, which means this, well, it doesn't mean this, but this is a 90-degree angle, and if this is a triangle, and this is a 90-degree angle, and that's 70, this has to be 90 minus 70, so this is 20, and, oh goodness, if I had drawn this right here, then I could tell you, that that has to be 70 also. So suffice it to say, maybe I could draw this, that this angle is also 70 degrees. And clearly this is not to scale because that's smaller than 45. I can tell. Alright, so the perpendicular weight component is what we want to find, and we have the weight components. We have the hypotenuse, we're looking for the adjacent, and I can say that the cosine of 70 degrees in this case is equal to the perpendicular weight component over the weight. And therefore, if I multiply the weight, 49, times cosine of 70, then I get the perpendicular component of weight. And that comes out to 16. I wonder if I should just do it on here. I'll just, I'm just going to write, I guess I'll do it. Hopefully my wife won't text me in the middle of this. Airplane mode, there I go. So 70 degrees cosine times 49, 16.7 or 16.8. And the direction of this is perpendicular into the hill. So use the perpendicular symbol into the surface. Parallel weight component, same kind of thing, except this is the opposite, and so I would use sine to find it. So it's just going to be 49 newtons times sine of 70. And 49 times 70 sine is 46. The direction of this is just downhill. Oop. Okay, I'm going to be neater. Normal force. Normal force is exerted straight out by this surface on the box. So it's like this. And I know that this normal force is equal to that perpendicular force because I know that in this dimension the box is not accelerating. It's just staying there. It's only moving in this dimension. So the normal force has to be the same as that, 16.8. And since this is perpendicular and into the surface, the normal force is perpendicular out of the surface. Friction, when you can do it, use the formula. The formula for kinetic friction, because it says the box is sliding, is just mu times the normal force. And mu in this case is 0.6. And the normal force is 16.8. And friction must be 10. So 10 newtons, 10.1 newtons. The direction of the friction, since this is sliding downhill, friction resists motion, so friction is going to be this way. And that must be all the forces, because now I'm asking you for the net force, so we just need to add up all the forces. You can either do, you can find net force this way, but we don't know the acceleration. That's what we're trying to find in the end. That's what we're looking for. So we have to do it the other way, where we add up all the forces. So first off, this weight, the original weight, the actual weight, we traded in a long time ago for these two components, which are equivalent to that weight. And of these two components, the parallel component and the perpendicular component, this one gets canceled out because it's equal and opposite of the normal force. So those cancel one another. So all we're left with is two forces. We're left with friction going uphill and the parallel weight component going downhill. And I'm going to arbitrarily decide to call this positive direction and this is the negative direction. You don't have to make a note, but I'm just going to write uphill equals positive. That's just for me, just a note for me, so that after I get my number, my numerical answer, I can figure out the actual direction. So 10.1, that's an uphill force. Let me write this, and then I'll write it again. So the net force, adding up all the forces that don't cancel, would be the force of friction minus the parallel weight component. Now I'll write it again, but I'll put in the numbers. 10.1 newtons minus 46 newtons. Negative 35.9 newtons. So instead of on the answer key or the answer sheet writing negative, I'm going to write 35.9 newtons downhill. And I just realized that I didn't put in the direction for friction. Direction for friction would be uphill. And finally the box acceleration. Now I can use this. The net force is negative 35.9 newtons, and that equals the mass of the box, which is 5 kilograms, times the acceleration. So it's just 35.9 divided by 5, negative 7.2, or 0.18 or something like that. Which means about 7.2 meters per second squared downhill. The direction of the net force and the